Hi guys, this is Mr. Granillo with your first lesson, which will be chapter section 8.1 for graphing quadratics. Hope everything is going well. I know you guys are probably enjoying this a little too much, but don't forget, you don't want to go through life not knowing how to think. So we got to keep things going. And we certainly don't want to go to school over the summer, right? So let's get through this the best we can, and we'll go from there. So the first thing is we're talking about this chapter, graphing quadratics. If you remember, I know it's been a while. I'm sorry I don't write very well with this stuff, but this was our quadratic equation, right? Ax squared plus bx plus c. If we were to graph that, it would make what we call a parabola. Okay. If those of you that are maybe taking notes, looks like that. Okay. So the parabola is really good at showing us a different type of graph. It's things that kind of go up and go in one direction instead of a straight line that goes up on one side and down on the other. Parabola starts at one point and maybe either goes up or it could go down. Now, some important points of a parabola. The first one is this point right down here. This is supposed to be going through 0, 0. Okay, we call this the vertex. The vertex is important. Okay, it's the point where our graph changes from our y values coming down to our y values going up, or we might say decreasing and increasing. Okay, the other thing that's important about the vertex is it also shows us where the axis of symmetry is. Okay, so that's got to be a vertical line going through that vertex, and we should remember that all vertical lines have the equation x equals some number. In this case, because it's going right through the origin at 0, 0, all right, then that axis of symmetry is 0. Now, axis of symmetry simply means mirror image, right? You can see that that red dotted line splits the parabola into two what's supposed to be equal parts. If you look at this on the Big Ideas website, on the e-text or ebook, they'll give you some other examples, and obviously their graphics are going to be much better than mine, and it'll be a lot easier to see that this half and this half are exactly the same. Okay, so these are the types of things that we're going to be graphing and dealing with. Okay, and parabolas, again, the important parts are the vertex and the axis of symmetry. Now we got to talk about one other thing, but let's do something a little different first. So let's take a look. Okay, actually, so the graph, if we just graph this equation y equals x squared, that's the most basic graph that we can graph because there's no other letters, no other numbers. There's a 1 in front of the x squared, but that's about it. So this is going to just kind of go like this, okay? It goes to the point 1, 1, negative 1, 1, 2, 4, and negative 2, 4, okay? So those are kind of the basic points that we want to start off with y equals x squared. The other thing I want to talk about with this are these terms that we started to talk about way back when, domain and range. Now, do you remember what values the domain has to deal with? That's right, the x values, which means the range has to do the y values. Now, those arrows on the parabola tell us that this thing continues forever in both directions. So the domain is going to be really easy for all parabolas. The domain is going to be all real numbers, and we use that little symbol to say all real numbers, okay, that R with a double line. That's always going to be the domain. The range, however, is a little different. The range is talking about what y values is this parabola going to cover. Well, it's never going to cover any y values down here, right? It's only going to, if you look at the arrows, it's only going to start here and work its way up from there. So the way we would describe that range, we'd say we're going to use all y values greater than or equal to 0, okay? And so that's going to be the domain and the range for for that parabola. The range might change depending on the parabola. So again, if I start off with just my normal, I'm going to do this in a dotted line, okay? But if this is my normal y equals x squared graph, I want to be able to graph something a little bit different. I want to be able to graph something that has maybe a 3 in front, right? So if you remember from our A, B, and C, now A is 3, okay? What that does, what that 3 does right there, is it multiplies all of your y values by 3. So all of your y values are going to get a lot bigger than they were in this original y equals x squared. So you remember the 0.11? Well, now it's going to be 1, 3. And this is going to be negative 1, 3. And instead of being 2, 4, it's going to be like 2 and 12 up here, way up high. Okay, so what that 3 does is your vertex stays in the same spot, your axis of symmetry stays in the same spot, but now my graph is going to get skinnier, okay, by a factor of 3. We call that a vertical stretch. Okay, so anytime that A is greater than 1, we're going to get a vertical stretch. It's going to make it skinnier. If it was a 4 or a 5 or something like that, it'd make it even skinnier, right? And it can get really skinny. So vertical stretch, that's one of the things you're going to have to identify. Now, the other thing is, again, starting with, let me try that again here. Get rid of this. Okay. Sorry, I'm getting better used to this. Okay. If this again is y equals x squared, that's always our base graph. Okay. Now, if I wanted to graph something like 1/4 x squared, right, where this is a fraction, that's going to make all my y values smaller, right? When I multiply something by a fraction, if I want to take a 4th or a 5th or a 10th, it's going to make it smaller. So what it does, it makes all my y values shrink up, and it ends up making them go out here wider. Okay? We call that a vertical shrink. Okay? But what it really does is it makes the graph wider. And so we would say A is less than 1, right? So if it's a fraction, it's going to make the graph get wider. If it's bigger than 1, it's going to make it skinnier. But we call it technically a vertical stretch and a vertical shrink. Okay? Now, there's one more type of graph that you're going to have to do on this lesson or deal with. And again, if we start with y equals x squared, and that is y equals, let's say, negative 2x squared, okay, or something like that. I want to make sure we don't do anything else. So the negative sign now, we have two things going on here. We have the negative sign and we have the 2. Well, we should know that the 2 is going to give us a vertical stretch. It's going to make it skinnier just a little bit. But the negative sign is what we call a reflection or a flip, right? So that negative sign, we're going to make it skinnier and we're going to flip it upside down over the x-axis, okay? So be on the lookout for that negative sign. You got to flip it upside down, all right? So that's the heart of our lesson today. We're going to kind of take each day a little step by step, kind of like what we did with solving quadratic equations. We're going to do that same thing with graphing. So Let's do one last example that I want to make sure we understand. Okay. And let me graph this guy. Let's graph this. Okay. So, two questions. One, actually quite a few questions. Find the axis of symmetry, find the vertex, find the domain, find the range, tell what's happening in this parabola. Well, the first thing we want to do, and you can pause the video right now if you want to try to do this on your own in your notes or whatever, that'd be a good idea. But the first thing we want to do is we want to draw that axis of symmetry right down the middle of the parabola. Okay. Now, the axis of symmetry is going to be x equals some number. Well, what number does that x value go through? Well, let's say it goes through 1, 2, let's say -3. So we'd say that the axis of symmetry is -3. Okay. The next thing we want to do is find the vertex. Well, that's that bottom point right there, right? So the vertex, we want to give it some coordinates. All right. Well, we already know the axis of symmetry is at -3, and so we know the x value is got to be -3. But what's the y value? Well, probably -2. So the vertex is at -3 and -2. Okay, let's talk about the domain. What's the domain? Well, we should know that because I already told you, always going to be all real numbers. But the range, well, you can look at two things to help you out with the range. You can look at the vertex, the graph, or you can look at the y value of the vertex. And in this case, this parabola is going up, and so we'd say the range is all y values greater than or equal to -2. Now, if we happened to be dealing with a graph that went upside down, right? The range, I just want to talk about the range for a second, because that's the only thing that's really different. We'd say that range, y is less than or equal, right? Because it's going down, right? And we would say is -1/2. Okay, so that vertex right there, that vertex is at y equals -1/2. So you got your axis symmetry, your vertex, domain and range, and then when we're graphing it, we might have to flip it upside down if it's negative. If a is greater than 1, we stretch it vertically. If a is a fraction, we shrink it vertically. So hopefully this answers your questions on the first lesson. If you have a specific question, like Mr. Grigny, I need help with number 7 or whatever, email me and I will do a problem on this whiteboard and send just you that video, and hopefully answer your questions that way. Make sure you stay tuned into your student view account, because that's the best way I'm going to have to to email you things. All right. So I hope you're getting some work done and being good for your parents. We'll talk to you with lesson 8.2.